Hi everyone, we're going to verify trig identities with natural log. There's 4 problem sets here, 4 problems basically, and I'm not going to go over the properties of natural logs. So I'm assuming that you know the properties of logarithms. If you don't, then you're going to dislike the video because you're not going to get it. So first thing I'm going to do on this one is go ahead and write this as ln of 1 over cosine of theta, which is the same as ln of cosine of theta to the negative 1. So it's the inverse. Just like if I said 2 to the negative 1, we know that is 1 over 2. Or 1 half to the negative 1 equals 2. Now, using your properties, I'm going to use my power property and move that negative in front. So that gives me negative ln of cosine of theta. So it's pretty simple. It looks scary, but it's not that hard, really, if you know your properties. Now, the next one is just an expansion. We're going to use our product. So we have ln, rewrite this as sine of theta over cosine of theta. Now I'm going to expand it. For example, ln of a over b is the same as ln of a minus ln of b. You're just expansion. This is called the quotient property. And so when I do expand this, I'm going to do the same thing. So that's ln of sine of theta minus ln of cosine of theta. And it's just using your quotient property. And this one, we're going to condense this. So what I'm going to do is write this as, we know that ln of a plus ln of b equals ln of a times b. So I'm going to put those together, and I get 1 plus cosine of theta times 1 minus cosine of theta. And that gives me ln of 1 minus cosine squared of theta, which is ln, you know the identities, that's sine squared, sine of theta squared. And I'm going to use my power property. Remember, ln of a to the power is the same as p times ln of a. So I'm moving this 2 in front, and I get 2 times ln of sine of theta. Okay, and I believe we have one more. Or is that it? We have secant. Again, I'm going to expand this, or condense it. It's the same thing as ln of a plus ln of b equals ln of a times b. So that's what I'm going to do. Ln of secant theta plus tan of theta times secant of theta minus tan of theta, which is ln of secant squared theta minus tan squared of theta. And we know this equals 1, so we have ln of 1. We know that ln of 1 equals 0, and that's just a basic property, because we know that e to the 0 equals 1, if you want to rewrite it. And that's all. The next thing we're going to do is deal with inverse trig identities. Thank you, and have a nice day. Bye-bye.